Hello everyone, in this video I'm gonna talk about histogram equalization. Histogram equalization is a technique used to improve contrast in images by expanding the range of intensity to as uniform as possible histogram. This figure shows image with its histogram and histogram after equalization. So the main objective is to go from given distribution to uniform distribution. Here we deal with the normalized histogram because the histogram is a probability density function of the random variable, which is intensity of pixels. So the probability is from 0 to 1. So we want P of S equals 1 over L minus 1. From probability theory, if P of R and the transform function T of R are known, the probability density function of the transformed variable S can be obtained as follows. B of S equals B of R times the absolute derivative dr over ds. Let's assume S equals T of R equals L minus 1 integral from 0 to R P of W dw. If we calculate ds over dr, we get L minus 1 times P of R. Now we include this here. We get 1 over L minus 1. And this is what we want, a uniform distribution as we mentioned in the previous slide. So the transform function that we want to use to get a uniform distribution is S equals T of R equals L minus 1 integral from 0 to R PW dW. But that in continuous values. And images have discrete values. So to go to discrete values, we convert the integral to summation. So the transform function become, here example of histogram equalization. Suppose we have image with intensities from 0 to 7 and number of pixels for each intensity. First, we calculate the weighted histogram P of RK. Then we calculate the cumulative histogram. The next step is multiplying by L minus 1. The final step is quantize the output. Now let's move to Visual Studio. Thank you for your attention and see you in next lecture.